Let's just start off with a 100-room apartment. It's going to be a real simple, basic apartment, just so you understand. We need to calculate these from a fixed unit, and the fixed units can be converted over to GPM using the Hunter curve. But you need to understand fixed units come from code. There are plumbing codes out there that you have to follow to come up with the total fixed units required that will give you the GPM and demand. But backing up just a little bit, and here's my 100-room apartment again. Slow down just a second. Pay attention to me just a quick minute. Take the time when you're getting ready to do a pressure booster application to make a very simple, crude sketch. This is complicated enough right here. But the question to you should be, what are you trying to do? And very simply, what I'm trying to do, there's a critical fixture at the top of this 10-story building that I've got to maintain some minimum pressure on it no matter what. In this case, I'm going to say that minimum pressure is 20 pounds. You make anything you want to. I got a tank. I'm going to make it 20 pounds. That's all I need to do. So basically, it's going to be 20 pounds, and we'll go from there. Now, if you take a quick look at the 20 pounds, and that's at the very top. Let's see if I can put my way out of this. Excuse me one second. I am having a little difficulty getting the screen to close. I don't know why it came up. Here we go. I think we're okay now. Is everybody still with me? I hope I haven't lost anybody. 10 stories high, 116 feet, and I want to make sure there's 20 pounds minimum at the top. Now, I've got a pressure booster. I've got to look at city water pressure. I've got to come up with the demand. So real simple, what are you trying to do? First thing over, it's very critical you maintain this. You need to go to the city and find out what that minimum pressure is going to be. If it's 40 pounds in this case, fine. And you need to write a letter. Yeah, write a letter. They probably won't give you one. Ask them to send you a letter. They won't give you one. You write them a letter. You put in your file who told you the minimum city water pressure was 40 pounds. Somebody's got to take the responsibility for that. And if you're designing one, you really can't. The information has to come from somebody else. But you need to record where that 40 pounds came from. Please listen to me and do that. Keep a lot of problems out of your life. You don't want to fool with this. So taking a look at a 100-room apartment, I got 10 stories high, 10 apartments per floor. Each apartment's going to have a bathroom group and a kitchen sink. I'm going to keep it real simple. No washing machines, nothing else, just real simple. Bathroom group, faucet, water closet, and in the kitchen, same thing, sink. And that's it. City water pressure at street level, static is 55, but the minimum is 40. That means under no draw that city water pressure is 55. That's what the static means. Residual or minimum city water pressure is going to be 40 pounds because when I draw the demand, the pressure drops to 40. So I've got to size my pressure booster on the 40. I have a backflow preventer and a water meter. Everybody understands we got to have those. So a real simple sketch without boring you too much is where you got to start, you got to understand what you got, and we're 10 stories tall. So here's a typical fixture count right out of the codes, the way ASHRAE put it out, I think about 1967, and every code in the country still follows these. You'll see something called a hot water fixture old and new, and a cold water fixture old and new, and you see the total count. So if I'm looking at water private flush valves or private flush tanks, in this case we're probably going to look at flush tanks, as you work your way down you see the fixture counts. Now you need to check your local codes. I suspect they use the same counts. Every plumbing engineer I talk to is still using these old fixture counts from Hunter, putting the factor on them is what they're doing. There are some new fixture counts out that are acceptable for private. The only time they're going to change is private. If you look at the very bottom of the slide, you'll see the only changes there are laboratory private, where the old was 1, the new was 0.7 at the very bottom. Now that's the total, and we're assuming the cold is 3/4 of that, so the cold is 0.75, the new is 0.5, hot water is 0.75, 3/4 of the total, new is 0.5. Not trying to confuse you, I'm trying to get you to understand in the code, under private fixtures, there is the ability to reduce the count. I'm not seeing people do that. I'm not telling you it's the right thing to do. I'm just alerting you that it's in the code. So now we got the fixture count. And with a pressure booster, we're looking for what? The total flow. Once the water gets to the apartment, they can break it down to hot and cold. I've got to have the total number of fixture units. So that's all I'm really worried about at this point in time. So where am I going to get this from? I'm going to go to the local plumbing codes, and here's some typical examples. And every state in this country is using ICC, some version of that, called IPC, International Plumbing Code. And this is just some pictures of some local codes around us in close states close by. And all of them use International Plumbing Code, and they all go back to the same fixture count I just showed you. The point I'm trying to make is the local plumbing codes rule. Chris Edmondson can't tell you what to do. You've got to go to that local plumbing code, see what they demand, and you've got to follow that code. That's the code you go by, because the local plumbing inspector rules. The local plumbing inspector can demand anything they want, even if it's not in this code, because they're going to control whether you open or close your building. So don't fight it. Go ahead and get in the habit of contacting that local plumbing guy, the local plumbing code official, see what they want. Odds are it will be right out of these books, right out of what I'm teaching you. But again, remember, I don't rule, they do. That's the important lecture that you need to get from me today. If you go back to the apartments, go back to the fixture count, start taking a look. I said each apartment had in it a shower, a kitchen sink, and we're going to add them together. We're going to assume flush tanks. I would not put flush valves in a typical apartment. A flush valve takes a lot of water right up front. We're going to use flush tanks. I think that's pretty much where we need to go with this fixture count. So here we go. If I got 100 apartments, each apartment's going to take about 8 fixture units, 6 for the combination of bathroom and 2 for the kitchen. 2 for the kitchen is just a water sink in there and a faucet. In the bathroom, we got the faucet, shower, and water closet. That's 6. Add the 2 together, I got a total of 8. And again, I'm not worried about hot water this time. I'm just worried about the total fixture counts. If I got 100 apartments and 8 fixture units, that's 800 fixture units total. And where did I get the 180 GPM from? We have to go to something called a Hunter's curve, which we'll do in a few minutes to make sure you understand where it came from. But before we assume that we got the exact right amount, I want you to recognize in the real world that we live in, people are putting in full body showers. And we can argue whether they meet code or not. And in fact, there are some lawsuits going on among some cities stating they don't. We don't want to get caught in all that. But the message is we just allowed 6 fixture units total for the bathroom, 2 for the water closet. We just allowed 6 total for the bathroom. You come along and put a full body shower in it, you're going to be short of water if that's what you used. And if you're doing the plumbing design, if you're picking the pressure booster, you best know what kind of showers are going in your apartments. As to whether they're legal with the city or not, I'm not going to pick that battle. We're doing the pressure booster, right? We're sizing. We're sizing the drain, right? We got to make sure we got enough water to keep the client happy, and that the full body showers may be a part of it, and you need to ask. And this is just to be interesting. Here's another one, and this is one I experienced in a hotel in Mexico recently. I call this the rain shower. 27.8 GPM of water in a shower. Look at this thing. Unbelievable. But my question is, if you are the plumbing designer, if you are providing a pressure booster, you've got to put that 27.8 GPM into your demand, or you're going to be short of water, and you're going to be in trouble. So you got to go further than the plumbing code as a message. You got to know what your client is doing, what your client's going to do with the water. And I like this one. Look at this one. This is a shower that's unbelievable. You get in that thing, I hope you don't drown in it. And the worst one I found was this, the $100,000 shower. Can you believe this? 18 shower heads, 6 zones, 65 GPM of water. Did you put that in your pressure booster? Can you afford to put it in your pressure booster? But if your client is going to be putting in these type of showers, you've got to put it in your pressure booster. By the way, it's going to take 250 gallons of water in 5 minutes. You know, I would love to be selling the water heaters to this thing. Forget about the pressure booster. But this is unbelievable. But again, if you're the plumbing designer and you're picking a pressure booster, you best ask these questions or you're going to be caught short. It's not enough to just look at the plumbing code. You've got to go to your building and dig into it a little bit and see exactly what's there. Here's Here's another very common mistake we see that really, really has caused problems. Do you have a cooling tower? Is a cooling tower on the roof of your high-rise building that you're supplying a pressure booster for? Sounds like a pretty simple question, but we find a lot of times that the cooling towers are in the mechanical engineering section of the design. And I don't want to pick at anybody, but sometimes those people don't communicate to the plumbing engineer, and sometimes the plumbing engineer doesn't recognize that there's a cooling tower on the roof of the building. Now, what you got to understand is cooling towers have blowdown and makeup. And the question to you is, if you've got a cooling tower on the high point or roof of a building, how you going to get water up there? You've got to put it into your pressure booster. Your pressure booster's got to get the water required, makeup water required, to that cooling tower on the roof. And in our world, that's in the mechanical design, not the plumbing. So you got to make sure the two people communicate. Again, know your project. Ask the question, is there a cooling tower on the roof? You want some quick numbers without digging into this too deep. If you got a 500-ton tower, I would recommend about 30 GPM, and that's based on a blowdown rate equal to the evaporation rate per the slide, which will give you 2 cycles of concentration for those guys who are on and want to really know what that means. That would give you, if you give it that much water, 30 GPM per 500 tons, and you can prorate that out, that'll get you to the point of 2 cycles of concentration. The message from this slide is this: that 30 GPM has to be where? Into the demand, added to the demand on your pressure booster. And if you don't, you're going to be short of water. And you can't be short of water. So that message out of the way, I think you kind of got that understanding. Now, on the other side of things, there's a lot of codes coming out. This is ASHRAE's 189.1, so-called green code, and you see USGBC has their stamp of approval in front of this thing. They are trying, and rightfully so, to reduce the demand on these fixtures. And if you have a building that's been built per 189.1 and stamped approved, then you would be told that the fixtures in that building would follow these max demands. And these max demands would be less than the regular code that we just went through. So again, you have to understand what you're doing, and you've got to dig a little bit deeper. If it's 189.1 building, which a lot of buildings are, then these are the max water flows fixture-wise that are supposed to be in that building. But you still got to ask the question: does somebody put a body shower in there? You can't control that. But be aware there's an attempt, rightfully so, to conserve water and to downgrade how much water we're using in buildings. So just to be tricky coming up with that demand. So it's just some areas you need to be aware of. So what is the required system pressure? We looked at demand and GPM. We're trying to figure out how much water we need. We're trying to make sure we don't miss anything. How much pressure do we need? What is the pressure point that we got to go to? Back to that very, very simple sketch that we talked about before, and I cannot emphasize this enough. Not complicated. Just do this. Put it down. What is the elevation? How many stories high is it? The critical fixture is going to be at the top. Is it a water closet? Is it a water tank? Is it a flush valve? What is the minimum pressure allowable at that critical fixture? What is that critical fixture? You got to do a little research. You got to ask. You got to understand what that is. How many apartments are there? Fine, but we're worried about pressure right now. Remember, 2.31 feet makes a pound. So I need that minimum pressure at the top of the critical fixture, and that's going to become very critical as we go forward for the new code bit. Then we got 10 stories of pipe, so we got the elevation. Now we also have friction. As we increase the flow through pipe, the friction goes by the square of the flow. If we double the flow, the friction goes up 4 times. Going the other way, we cut the flow in half, then the friction is 25%. So we got a piece of friction in here based on total demand in the pipe flow for pressure drop. We got a backflow preventer, we got a water meter, and we got city water. So you kind of get the idea. In this case, we're going to assume flush tanks at the top, and the flush tanks can work fine with 20 pounds of pressure at the top. So the critical pressure that we're trying to maintain under all demand loads is 20 pounds at the top. No matter what you do with the flow rate, no matter how many pumps you run, no matter what you do, you want to maintain 20 pounds put that critical fixture at the top of the building under all situations, and everybody's happy. That's what you need to understand about the pressures. So here's a little pressure booster selection procedure. And if you'll follow this, you'll stay out of trouble. I really think, I don't want anybody to get bored, but look at A. If there's anything on this whole little slide that's important to you, is A. Go to the local authorities, ask for a flow and pressure test at the city water supply connection to your building. Ask them to give you those test results, confirm them to them in writing if they will. Probably will not put them in writing, but they'll probably give you the report. If whoever gives you the report, if they won't put it in writing, you put it in writing back, and you certify that, and you've got now the minimum pressure and minimum flows available to you at your building to design from. That is the most critical thing I can teach you, and put that in your file. If you're taking a sizing a pressure booster, put down who told you what the minimum pressure was. So I can't not make it any clearer to you. This is critical to your whole future, and a pressure booster is establishing what will be that minimum city water pressure. I've been working a lot of old-timers. I'm not going to recommend this to you, but I work with a lot of old-time plumbing guys who tell me they're going to zero. And I said, you're crazy. He says, no, Chris, over the period of time that we've been involved in this, we see the city water pressure from cities gradually deteriorating. So that's to the extreme, not a recommendation, but I just want you to be aware some of the old plumbing guys don't believe what they're being told because they've been burnt. And remember, with plumbing, you can never be short. That's part of the problem. Next part of this, obviously, is to go to state and local codes, get the Hunter curves, get the fixture units, follow the codes to get you demand. This item C, we're not worried about breaking hot and cold water right now. That would be if you're worried about that part of the piping. We're just worried about total demand for the pressure booster. Item D, the simple system sketch. What are you trying to do? Where is the critical fixture? How much water pressure do you need at that critical fixture? Where is it located? Item E, we've looked at ASPE, looked at ASHRAE, and we looked at a B&G design manual. All three agree. And what they agree to is, how do you size the pipe? How are you going to size the pipe for your pressure booster? Because pipe size will determine the what? The water velocity at full demand and the friction loss. And that friction loss pressure-wise has to be into your pressure booster calculations. Item F, calculate the total pressure booster required in the pickups, pump, and write a spec. Now, if I take everything in this little chart that I just gave you and try to apply it, here's what you're going to get real fast. Here's a simple little chart that's been put together that we can give you a PDF on and email it to you if you like. But a lot of engineers have actually printed this thing off in color, and I find it with the designers on the wall. I know all you young kids like to run computers, fine. But when you're in a fast, big hurry trying to come up with a pipe size that's acceptable to ASPE, to ASHRAE, what size can you go by? The guideline would be 5 pounds of pressure drop max at full demand. That would be the max, and that's kind of the red line across the top, the horizontal line above the yellow line, the red line. That's the 5 pounds of pressure drop per 100 feet of pipe, maximum allowable pressure for plumbing. Coming over to the right, you see a purple area, and you see 8 feet per second circled. So anything above that purple line would be 8 feet per second. So here's the magic of the chart to keep it real simple. Anything in yellow, good pipe size. Anything in purple, bad pipe size. Anything in red, bad pipe size. You're trying to pick your pipe to stay below 5 pounds per 100 feet of pressure drop and or below 8 feet per second. You follow those two guidelines, below 5 pounds of pressure drop per 100 feet and below 8 feet per second, you're going to have a good, solid pipe size for your plumbing design, acceptable design, and very reasonable, and something that ASHRAE and ASPE both will support you if you need a support. Another interesting thing this little chart is we put the Hunter curve on the bottom. In our previous apartment example, we came up with 800 fixture units. And 800 fixture units means we got to pick a pipe size, right? We got to come up with a demand. That demand is per Hunter 180 GPM, which is right off the bottom of the chart. When you see the very bottom, the 180 at the bottom, that is actually Hunter's curve with a flush tank with fixed units above it. So the bottom line is now we have a way to pick our pipe sizes we want to stay below the 5 pounds per 100 feet max pressure drop and below 8 feet per second. People, the kids up listening to me now understand maybe you don't like this chart. There are handheld applications now for pipe sizing. This particular one, we can tell you where it comes from. You just go online and research where you get pipe sizing, it'll pop up for you. But basically, a lot of engineers are saying, where can I get PVC pipe information? Well, it's right here in this little app. Also copper, also steel, also English, metric, and even Spanish is coming right behind it. So here's another, for you young engineers that don't want to play with color charts, you can use your little iPhone, you can pick these up, and it works quite well. So let's go back to the pressures that we need for our example. And we got to come up with the pressure required for our pressure booster. We came up with the demand with the fixture counts. Now we're trying to come up with the pressure. Remember, the critical fixture was a flush tank at the top. That's going to need 20 pounds minimum, no matter what. Remember, we had to have friction loss. Our max allowable pressure drop per 100 feet is 5 pounds. So if I look at that chart, I had about 110 feet of pipe roughly. So I'm going to say under full flow, I would not exceed 6 pounds. Maybe a little heavy with the 6 pounds, but that would be potentially my friction loss would be 6 pounds. Elevation, I was 10 stories up, 115 feet, 2.31 feet make a pound. Remember that? So I need 50 pounds of pressure at the street just to get water to the top. Then I got a backflow preventer, 12 pounds of drop, and I got a water meter at 8 pounds. So the total required pressure at the discharge would be 96 pounds. Everybody understand that? The minimum city water pressure is 40. So how much have I got to make up with the pressure booster? My pressure booster has to produce 56 pounds of pressure. Now, this is in a maybe a little hard form for you guys, but we got a little chart for you. If you take this chart along with the procedure we gave you before and just simply fill it in, you can't go wrong. It's kind of a check-off. Doesn't matter whose pressure booster you're doing or what, you got to deal with these issues. And basically, I'm suggesting you put this in your file. You kids can make a scan and scan it into your file electronically. I don't care how you do it, but you need some record of how you came up with the total GPM and the total pressure required for your pressure booster. So very simple here. If you walk away through it, we start off with the fixture units, 100 demand curve to get the GPM. So you got a record of that. You got it sitting there. Then you walk your way through. First thing, obviously, where is that critical fixture? What is it? Is it a tank? Is it a valve? You got to have that number. You got your friction, your elevation, pressure drop to a water heater. If you have a reducing valve or check valve, a backflow, whatever you got. If you walk through this, you'll come up with exactly the pressure that you need, and you can throw it in your file, and you're there. And very quickly, I don't want to bore you with this, but as an old guy who's been in this business way too long, I see things. And here's this 100-room apartment example that we just talked about. And in red, I just popped in all the numbers we talked about, 800 fixed units from 100, 180 GPM demand, came through all those pressures we talked about. And now you got a permanent record of what you did and why, and then you know the numbers. And my pressure booster needs to be what? 180 GPM with a boost of 56 pounds.